Hey everyone, welcome back to the shop. Today we have a small lathe project to do. And what I mean by small is that we have a couple of these pieces right here. They have to do with a quick connect for a prosthetic arm. And the problem that they have with these is that they are machined with an M10 thread, and what they need is a 1/4 UNC thread machined on these guys right here. So we got two of them to modify. These belong to my buddy Joe over at the welding and fab shop. It's actually his, and his son Bone actually has a prosthetic on his right hand there that he uses. And I don't know the full dynamics. I haven't seen this attachment. I'm not really sure exactly which one it is, but I do know that it's a prosthetic that he attaches to his right arm and uses it for things. And again, the problem is that the thread size is incorrect. I believe what it is that you have one attachment that is made by one manufacturer with a metric thread on it, and it needs to be attached to his arm, which is made by a different manufacturer that uses 1/4 thread. And these are not available with the 1/4 thread on there. So what do? That's where you find a machine shop and a machinist with a lathe that can modify them for you. So it's a simple job that can be done, and that's exactly what we're gonna do. Joe brought me one of these 2 or 3 months ago. He brought me one and I modified it for him, and they took it and he says it worked perfect.
Let's go, Bone. There it is, there it is. Yeah. Good. Oh yeah.
So he's got two more that he wants to have modified, and I thought this was a great opportunity to go ahead and get some good video for you guys to share on the channel. And I'd like to get you zoomed in, get you some nice tight shots of this, of the turning and the threading, and show you how we can knock these parts out. They are pretty small, so it's a little challenging to get them held properly and be able to get all the way up to that shoulder to do our turning and threading, but it shouldn't be any problem. We'll get you down here a little closer. We'll show you our work holding. We're gonna look up the thread pitch diameter, because I do not have any no-go gauges for a 1/4 thread, which I find kind of funny, because I got a bin full of go gauges, some that belong to my dad and some that I bought at an auction a while back, and for whatever reason I don't have any 1/4, so that's a thread that I need to get and add to my collection in there. So we have a pitch mic that we can use, and that should get us there. We've got our machinery's handbook that's going to give us the information that we need to use our pitch mic, and we should be able to get these turned and threaded. So we'll get you down here a little closer so you can see what these look like. We're going to show you how we're going to hold them, and then we'll get over here on the Precision Matthews lathe and get these guys modified. All right, here's the two quick connects that we're having to modify, and you can see the thread on the end of it there. Not a lot to work with. About 3/16 I believe is how far back they're turned. And we'll just take it right up to that existing shoulder. If we need to clean that up a little bit, that'll be all right as well. All right, so this is the threading tool that we're going to be using today to get this done. You can see because of this particular insert there, it allows us to get up a lot closer to the shoulder that we need. So that'll get our threading done. And then for our measurement, we're going to be using our Starrett micrometers. And then we're going to be using this pitch mic right here. You can see this one's good for 20 to 24 threads per inch. So that's what we're going to use to measure our thread diameter. And we'll look in the machiner's handbook and see what the pitch diameter is going to be. This is what we're going to be using to hold it. So what this is just a collet chuck made by Technics. And these are some collet chucks that I use in the CNC lathe. But after discovering these guys, after I got my CNC lathe, honestly, I didn't know that this kind of stuff existed until I got the lathe. But then when I did, I saw the value in these, and not just holding tools in the CNC lathe, but holding work pieces there as well for the manual lathe stuff. So this is an ER25, and then I have an ER25 collet right here, also Technics. And this is an 11 to 12 millimeter collet, ER25. And these two diameters are turned to the same. So we should be able to put this in this collet, and I know it works because I did it once before, and be able to hold that guy in this collet chuck and to be able to turn and thread that. So this we'll just put in our 3-jaw chuck, clamp it here, put our workpiece in there and tighten it up, and this is what's going to help hold our workpiece to get the machining done. All right. If we open up our handy dandy machinery's handbook here, I've already got a thread marked, or I'm sorry, a page marked on here so you guys can see. If we go to our machinery's handbook and the threading information, and we come down our list, we're looking for a 1/4 20 thread, and we'll just use a 2A class. And then come right over here. This is our external pitch diameter, maximum and minimum right there. And we come down to our pitch diameters, maximum, minimum. You can see I'm just going to round up to 213 thousandths up to 216 thousandths right there. So that's our range that we would like to be in whenever we do our turning and threading. Let me find the micrometer here. We'll use this micrometer to measure this pitch diameter right there for our 1/4 20 threads that we're going to turn and thread. All right. So we'll go ahead and move over to the lathe, and we'll get all of this set up, and we'll start turning and threading those parts there. Okay, let's go ahead and get the lathe set up. So we have our Technics collet chuck here. We're going to put it in the 3-jaw. Go ahead and get our collet installed into the nut. All right, and then we have our workpiece. Again, these are turned to the same diameter right here, so it'll be able to hold it in two places there. I'm going to try to push this back as far as I can. Something like that right there, but still allow me room to get our threading tool up in here and thread to that shoulder with, that looks like we'll have about 1/8 of an inch clearance between the tool and the face of the nut. So let's go ahead and get that guy tightened up. That should be good. Let's spin it up and see what it's going to look like. I can see a couple thou run out on it, but that's not a big deal. The parts doesn't have to be 100% concentric. If it's off 2 or 3 thousandths from the cone-shaped end of it, not a big deal. So we're going to leave it right where it is, and we'll find some tooling. We're going to turn it down to 250 thousandths, or actually 245 thousandths is our diameter that we're going to want, and then we'll thread it. Okay, we've got one of my favorite tools set up. This is a CNMG 431. We'll use that for our turning. Go ahead and measure this diameter of where we are. All right, that's measuring 393. Almost 150 thousandths to come off here. So first thing, let's go ahead and find that face. That's our face. I'm going to go ahead and zero out our, let's see, zero out the Z, and then I'm going to use my mag back indicator over here to set a 0 on the dial indicator. Just like so. And we'll go ahead and start turning this down. Just going to take 50 thousandths a pass. Make sure you guys can still see that. I'm trying a little bit different camera for you for this video. I mean, I've used it before, but definitely trying to get you some more clarity on some of these small jobs like this. A little bit easier to see in the video. Let's see where we are. So we got 60 thousandths to come off of that. So I'm just going to split it in half. 10, 20, 30. Using my air hose so you can blow the chips off of the surface there that you just turned. Come back in here with our mic. All right, so we got 25 to go plus another 5 thou clearance. So I'm just going to take 29 thousandths, 10, 20, 5, and 4 equals 29. All right, that should be our diameter that we want. Now I am going to come in here with a round nose grooving tool and machine an undercut for the thread as well. Just checking our diameter. I realized that my air pressure was a little bit low, so forgot to turn on the Kaiser this morning. Go ahead and get it kicked on. All right, we'll get back on this threading now. This is our tool that we're going to use to machine the thread relief or the undercut. So we have this insert here that has a full radius nose on it that is 16th wide, 62 thou, so a 1/32 radius. That's the wrong tool. These MX22 tools by Walter are excellent. Highly recommend them. I've shown these many times because I love them. These inserts come with 4 cutting edges on them. You can get them in threading profiles, grooving profiles with square nose, round nose, and I'm sure many other classifications of thread sizes as well that you can get in this insert here. So I keep a variety of different round nose radius inserts for doing thread undercuts and cutting the radius in a corner of a shaft or shoulder. In our case here, let's see, we've used that one. Still looks pretty good, but we're going to go to a new edge. We'll use number 2, cutting edge number 2. There we go. All right, we'll go cut our thread relief, should I say. Okay, let's get the thread relief machined. All right, there's a 0 on our X, and we're going to go 65 thousandths deep. Double depth of your 20 pitch thread. Just widen it out a little at a time as I go. That's 65. I'm going to go a few thousandths deeper. All right, we got it widened out enough for our threading tool. Now I'm going to go ahead and bring it up to this face here, and we're going to clean this up using our radius tool there. I've got one of my other MX22 threading inserts installed there. We're just going to use that to cut a chamfer on the outer edge. That's a larger tool, so it just gives you a little more cutting surface there to work with. I think that's going to be good enough right about there. Before we begin threading, I thought I would show you how I got my dial indicator set up here as a visual reference on where to stop whenever we're threading. All right, so we're going to go ahead and gauge this. I am running it slow so that it's nice and slow and controlled and easy to follow, and we don't risk crashing into the shoulder and tearing everything up. We are running 180 RPM on the lathe. But if you look down here, we've got this edge mag back indicator, and I've got our first 0 set to where I would like the tool to stop. So we're going to go ahead and I'm just going to engage the half nuts over here on the right side. And I'm visually looking at the tool now and stopping where I think it needs to stop. But I did jump the gun a little bit, and you can see we're at the 80 mark, minus 80. But if we run all the way up here to the 0, our tool is still clearing. We'll go ahead and do that again. We'll go ahead and engage. So what this is doing for me as I'm threading, I'm looking down here because I'm looking at the tool, but in my peripheral, I can look down here and I can see this needle moving around, and I know that it's going to come around here to the 0, and that's where I need to stop. So this is a visual aid in getting our tool up to the shoulder where we need to, and you have your right hand on the lever for the half nut, and as soon as you see this needle start coming around and make a movement, you're pretty well in the clear to stop. Now there's a little bit more to that. You just got to have a little bit of eye-hand coordination. But once you do this and you do it enough and you practice it and you practice it, you start gaining that muscle memory for your eyes, your mind, and your hands all at the same time. And it's pretty simple to get this work done. So anyway, just wanted to share that little tip with you right there. This is a big help whenever you're threading up to a shoulder, especially like if you're going up inside of a bore and you cannot see the tool. You go ahead and you get you an indicator down here set to your 0. It'll, as long as this doesn't move, if you don't move it, this is going to get you there in the same spot every single time, pass after pass. All right, so let's go ahead and get it threaded now. All right guys, I think we're ready to thread. I've already got the tool touched off. We've got a 0 set on our cross slide and the compound as well. I'm going to go ahead and we're going to put some of this blue Sharpie on here. All this is to help you see what's going on. We have a lot of people ask, why do you color it blue? It's a visual. It just helps you see it. All right, we've already got our 0. I'm going to go in 1 on the cross slide here. I'm sorry, the compound. We'll go ahead and scratch it. All right, lined up over here on my 0 perfectly, the very first pass. We'll back it out, and we're going to go ahead, give it a check with our screw pitch gauge. The one inexpensive tool that I did not use, which caused the most expensive goof up that I ever made in the shop. I talked all about that in one of our recent podcast episodes. So I'm just using the screw pitch gauge to line up the threads. I can see that right there. That's another reason why that blue on there is nice, because you can see this. And I can tell that I'm cutting 20 threads per inch. All right, so let's go ahead and get started on it. Go back into our 0. I'm cutting 20 threads per inch, so on this lathe I can engage the half nut anywhere I want. Doesn't matter, we can engage it anywhere. Now I'm going to go ahead and add a couple drops of my dark cutting oil. Just like that. See, with the oil on there, it's hard to see it. It kind of covers it up. Such a small diameter. That didn't fall in. There we go. I did not calculate my depth. Let's see, 0.75 divided by 20 equals 37.5 thousandths. That should be our theoretical depth on our end feed here. This will be 25. We're at 30, and then we'll go ahead and do a measurement. It's looking pretty close, but I know we're going to have a few thousandths left that we need to bring it down to. I wrote down our pitch diameter that we're looking for, which is going to be 213 to 216 is what we want. So we've got our pitch diameter micrometer there. These are a little tricky. You got to get it top dead center. Get your reading on there. So right now we're at 230. So you got about another 15 thou to come off that. This takes us to 35 on our end feed. Get in here with our mic again and measure it. I set it down somewhere, now I can't find it. There it is, hidden in plain sight. Okay, we're at 220 thou, so we've got approximately, I don't know, about, let's just say about another 5 thousandths that we need to bring it down. A little drop of oil. Getting real close. I'm going to take 2 thousandths on the compound. And I'm going to go ahead and measure that. I'm going to measure that again and see where we're at. These require a little bit more finesse and feel than your traditional OD micrometer. It's really easy to get a mismeasurement on that. That is measuring 217 thousandths on our pitch diameter. We're looking for a maximum of 216.4. So I think another pass across there, and that should clean that up and get it down into the range at which we're looking for. Okay, taking a 1/2 thousandths. Dialed in a 1/2 thou. Let's give that a check, shall we? That feels good. And I am measuring 216 thousandths on our pitch micrometer right there. What I'm going to do is, I've got, again, I don't have a go no-go gauge for this size. I need to buy some. But I do have a standard hardware grade nut, 1/4 and it screws on there beautifully. Nothing wrong with that at all. So I say we have that one on size. The only thing left that we need to do is soften up the edge. It's got sort of a sharp burr on there. Need to soften that up so it doesn't cut anybody's fingers. I've got a mill smooth file right here, and we're just gonna, not trying to take it down, we just want to remove the sharpness off of it. That's all we're doing. That feels better already, just like that. Well, I think that completes the first screw. That looks pretty good. The very back thread is kind of rolled over a little bit. I'm going to see what I can do with I'm going to see if I can find a real small, like a Swiss file, and get in there and kind of deburr that last little bit of thread that's breaking through in the thread relief. Well, we have got one of these guys completed. So we're going to remove this one and go ahead and get the second one finished up. There we go. Quarter 20 threads ready to go. All right, so let's go ahead and get the second one turned and threaded. All right, here's a little closer look at the two, the one finished and the original. You can see the size difference in the thread. But that's what they need, and again, they've already used this once, so they know that it works well. So this is what they're asking for. All right, so one more to turn and thread, and then this job will be finished up. Okay, we'll get this second one turned. All right, 19 thousandths, and we'll be there where we need to be. Looking for approximately 246 thousandths on the mic, and it looks like we're there. That should be good. All right, let's get this second screw threaded. I have already touched off and I've already verified that we are on the correct pitch. All right, still got a couple of thousandths to go. All right, let's give it another measurement and see where we are. Yep, still got a couple more thousandths to go. All right, it's still 1 thou off right there. I'm just gonna go ahead and run this nut on here just to see how it feels. And I think that's accurate. It still feels a little bit snug on that thread. So I think one more pass. And we'll have this guy. Okay, I've remeasured it and we're right on the thread pitch that we want. So this guy is finished up. I'm gonna go ahead and just get it out of there. And this job is just about finished. All right, well there's our 2 modified screws there, going from M10 down to 1/4 20 UNC. Everything worked out good. The work holding, the turning and threading without crashing into the shoulder, it all worked out well. I'm sure Joe and Bone both will be ready to get these back in their hands so that he can use these for his other attachments there. All right, guys, well, this is gonna wrap up the machining portion of this video, and I hope you enjoyed it. The single point threading, you know, while these were some small pieces that, you know, we had to work on, and not a lot going on with it, but, you know, single point threading is something that I know a lot of people enjoy watching on the YouTube channels, and I enjoy sharing it anytime I have an opportunity to show single point threading, especially over here on the manual lathe, you know. And I'm trying to do a little bit better with some of the camera work, especially for small detailed parts like this. You know, trying to use a better camera to get in there, get zoomed in, have a nice clear video for you guys to watch and enjoy. And hopefully, you know, the people that are out there watching and to learn is getting something out of these videos as well. But this is just a project that I'm doing for a friend, you know, to help out Joe and his son. And it feels good to be able to do something like this, you know, to take our equipment, our machines, our cutting tools, our measuring tools, and not just put them to work, you know, for the day-to-day work, everyday jobs, but, you know, do something where you're trying to help someone out. And that's what this job was for right here. And I was glad to share it with you guys out there, and I hope you enjoyed watching it. So that's gonna wrap that up. I'm sure they're gonna be happy to have these ready to go. And I think I got a little bit more to share with you in this video, some stuff that we've been doing in the shop this week. So we'll go ahead and add that. And other than that, I hope you guys enjoyed watching, and we'll see you on the next video. These 2 cans are the result of machining 5 of my drill indexes. top and bottom using a 3-flute finishing end mill. And these 2 cans are the result of machining 100 of my drill indexes, top and bottom, using a 3-flute chip splitter end mill. Big difference. This is all the aluminum from the first 100 drill indexes. We're going to take them over to the scrap yard and sell them.
It's a lot of chips.
Yeah, it is quite a bit, about approximately 120 gallons here. We got a couple of pieces of solid aluminum too. That old pallet jack that failed on us when we were moving our granite plate in, I'm tired of looking at it. It's going to the scrap yard. So we're gonna head over there and see what kind of cash money we can get back from this material here. You ready?
I'm ready.
Okay. Would you believe me if we said it's late August and we actually got our first cold front?
It feels incredible outside. I don't know how we're so lucky. 73.
Yeah.
Perfect.
Feels good out here. Perfect morning to get the scrap sold
Yes, it is.
before it gets hot. Building 6. Okay, here we go. Sure how you wanted to handle it.
I got a box already made with some of the turners I already got. So
Okay.
I just blend with that. Let me grab the box.
Yeah, those things are pretty heavy. You plan on picking them up? These aren't bad. Those are a little heavier right there. Yeah, I'll go.
I'll probably just bring it to the edge and
Okay, I'll give you a hand with it.
use that lift.
Yep.
I'll get him here.
Oh, okay.
Make him work a little bit different.
All right. Yeah, you got a whole box full of aluminum shavings over here.
You come look at him.
You come over here? Uh-oh, that one's got a little bit of trash in it. You can throw it back in this can right here. I missed that.
You had a little bit.
They're getting better at making them. Yeah, I'm seeing it real good. Standard support ALA 10-12, I think.
Nice. All right. Yeah, I'm gonna keep this. I'm sorry,
Okay,
just a pallet jack,
Okay.
and then
You come back and reweigh. I'm gonna have him pull you right here. We'll just throw it in that container right there.
okay,
And you'll probably take those 2 pieces on the inside.
okay.
Since it's only 2 pieces, you know what I'm saying?
Yeah, I know. You're just taking that kind over here, and then the solids go somewhere else.
They come over here, but since it's a small amount,
Yeah.
and I scale on the way in 20-pound increments,
Okay.
it'll be better for you.
All right.
Done.
All right. You got that box just about full of aluminum
Yeah.
chips there. So we have to go back off the scale, and then we'll come back in so that we can sell our other scrap that we have there.
That's totally cool.
I think he's going to let us come by. What was it before? 10,100?
Correct.
It says it's 95.40 now. Huh. 560 pounds? That's quite a bit of aluminum that we just sold. We don't even have those little solid pieces off yet. Yeah, that sounds good. All right, thanks, man. Thank you. Was it 140 pounds or so? 150 pounds? Well, I think that was a successful trip to the scrapyard, and I was going to go ahead and give you guys a total of what we had. So the aluminum chips, they call them mixed aluminum turnings. It was a total of 560 pounds. That's for the aluminum chips. The tin, which was our pallet jack, is 140 pounds. And then I had an aluminum intake manifold and a couple of aluminum pans that I had scrapped, and that was $24. So the intake manifold and the two pans paid $3.84. All right. And the aluminum chips for the 540 pounds paid us $84. I was hoping it was going to be a little closer to 100, but I was just taking a stab in the dark there. But they took away $12.60 for water, which is the coolant. So we already knew that that was going to be an issue, but I'm glad that we did what we did. So they detected that, you could see coolant here on the trailer, on the wood right here. And when the guys picked it up, they could see a little bit of water coming out of it as well. And, that's something that they deal with on the regular basis, especially working with machine shops. So what can we do? Here's two of the cans right here. I already dumped one of them, and we talked about this in a previous video. You can see how much coolant is in there just from draining them, and they've been sitting here for going on 2 weeks now, draining. But after we picked them up out of here, set them on the trailer, it was still getting coolant down in there. So I'm not really sure how we're going to mitigate this. I know there's ways to do it, but we're not really to that level yet. So we're just going to do it the way we have been, and collecting the chips, letting them drain, and we already know what they're going to pay for chips like this that has residual coolant still on them. I'm just glad they didn't give us a hard time about it. I mean, they didn't say anything about it. It was what's on the ticket right here. So in total, we brought home $82.94 back into the business here for our aluminum shavings. So you can see it's not a lucrative business for a small shop to make a bunch of money on your scrap, but it is the proper way to get rid of all of your scrap metals, is to take it to a recycling yard like that and sell it to them and let them handle it. And they'll send it off, and it'll be recycled back into materials that goes right back into industry. So I'm glad to get all these cans unloaded now. the TRM is getting filled up again. You can see we're still working on the next batch of 100. That's how many I've got left to do the bottom. And once we finish out that last bit right there, we'll clean the machine out. And hopefully pretty soon to follow this, we're gonna have another mill in here. I got word that they've been getting it on the skid, getting it wrapped up, and it should be coming hopefully within the next couple of weeks. We're gonna have it here, and we'll be setting it up right in this general area right here. And I'm really excited to see 2 Milltronics mills running at the same time making parts. Exciting times. But anyway, we just thought that this would be something fun to share on the channel, is our little scrap adventure there. I did talk to him about bins. That's SA scrap, by the way. I did talk to him about bins, and all they have right now is the big roll-offs, which we don't have room for. I was hoping that they would have a smaller bin, because I saw on their website something that we could, you know, set right out there and be able to dump the chips in as we clean them out. But they don't have any right now. But we're going to go ahead and get a business account set up. They gave me the card for the guy that deals with commercial businesses, and we're going to talk to them and see if that's something that we could get as an option later on. Maybe we can plan for having a small bin out here. So anyway, that's that. I'm gonna get back over here on the mill and keep making some more chips.